Hi guys. So this is the last lesson of this week. 4 in 1 week is kind of a lot, but remember there is no quiz this week, so hopefully it balances out. Yesterday we did kind of a throwback to Algebra 1 just to get ready for some new stuff in Algebra 2. Today we're doing that again. So yesterday was multiplying, called it FOIL. There's also distributive property, stuff like that. Today we're going to review some of factoring. Now factoring is a big topic and we'll be doing more of it in this class, but we are going to review sort of the more basic Algebra 1 level of factoring. So one type of factoring is called common factoring, and it's like the distributive property we did yesterday, but it's backwards. So this is called common factoring. And then we have something called trinomial factoring, and that comes into a different sort of few different categories. But in essence, when you're doing trinomial factoring, you're basically doing the FOIL method backwards. And then there's easier problems where the lead coefficient, and I'll point that out. If you don't have any idea what lead coefficient means, don't feel bad. But lead coefficient is 1. When the lead coefficient is not equal to 1, it gets a little more complicated. So again, when I get there, we'll just talk about it. There's something called difference of squares factoring, which is also FOIL backwards. It's related to what we talked about yesterday. I talked about something called conjugates. So that's going to be a thing. It'll come up like in one example and one homework problem. I think you'll find it easy. Hopefully you'll remember it from Algebra 1. And then finally you can combine factoring. So you can do one problem that has both the common factoring in it and trinomial factoring in it at the same time. So we're going to do a couple examples of that. Now, for many exercises, I'm going to use a very specific method. You do not have to do the same method that I do. You don't have to do your work the same way that I do my work. You're all coming from all these different schools. You learned this probably a couple of years ago with different teachers, so people are going to have their own methods. If you know how to do what I'm reviewing today and you're doing it your own way, that is totally okay. I'm not going to insist that you must do your work the same way I do my work, so don't feel pressured to do that. On the other hand, if you remember learning this back in the day, but you're foggy on it, or maybe you never really got successful at it, you've always had a struggle, then maybe my method that I'm using might be something new that you can try to do and will help you out. So just a kind of a disclaimer there. I'm going to do everything a very specific way. If you understand the work your own way, totally okay. Now, this method that I'm talking about does not apply to common factoring. The first 4 problems here, not what I'm talking about. Common factoring, and as usual, I'll do the evens, ask you to do the odds. Common factoring is where you look at the various terms in the polynomial and you ask yourself, what do they have in common? What number can you divide out? And you want to divide out the biggest number and the most things that you can. So for example, 16 and 20 can both be divided by 2. 2 is what you'd call a common factor. However, there's a bigger number than 2 that you can divide out of 16 and 20, and that would be 4. Now, can you divide anything bigger than 4 out? You might say, well, I can divide 8 out of 20, or out of 16, but you can't divide 8 out of 20, so that's not going to work. So it turns out 4 is the biggest number. Now, it also happens that both of these have negative signs, so you can actually factor out a negative 4. So the common factor, the thing you can factor out, you write it down, then you put parentheses. Inside the parentheses, you're going to write this expression after you've divided out the negative 4. So if you take negative 16x and divide out a negative 4, you're going to be left with positive 4x. Then if you take negative 20 and divide out that negative 4, negative 20 divided by negative 4 is positive 5, so I put plus 5. And this is the answer. This is considered factored, or to be in factored form. If you want to check yourself, you can go back and distribute this into the problem, just like we did yesterday. Negative 4 times 4x is negative 16x. Negative 4 times positive 5 is negative 20. You get back where you started from, so that means we are correct. You don't have to do that. I'm just trying to illustrate how what I'm doing is basically the distributive property in reverse. Look at the next problem. We got negative 7n to the 9th minus 14n minus 14. Now these two both have 14. Does that mean 14 is a common factor? Well, it's common for those two terms, but we need something common for all terms. And you cannot divide a 14 out of a 7. However, if you reverse that idea, you can divide a 7 out of a 14. Again, like the last problem, this one has negative signs, so we could actually factor out a negative 7. Once you do that, if you have negative 7n to the 9th and you divide out that negative 7, you're just going to have n to the 9th. If you look at the negative 14n, divide it by negative 7, you're going to be left with positive 2n. And then negative 14 divided by negative 7. Oops, I got to back up. I realize I just made, no, I didn't make a mistake. That's fine. All right, forget I said anything. Back to where I was. Negative 14 divided by negative 7 is going to be positive 2. So let me rewrite this answer a little more clearly. And again, if you want to, you can distribute the negative 7 in there and see if you get the original answer. You will. I'm not going to waste your time doing that. But there it is. Now, I just realized I never checked number 2, so let me check number 2 and number 4. I'll scroll down right now and do that. So there's number 2, and there's number 4, exactly like it should be. So those are common factoring. Yeah, I'll leave it at that. You do 1 and 3, be sure to check yourself. Now, the rest of these, well, almost everything else is trinomial factoring. It's called trinomial factoring. Tri means 3. There are 3 terms here, so that's why we call it trinomial factoring. It's basically the FOIL method in reverse. So this times this is going to equal that, and this times this is going to equal that. And that's fairly simple. The hard part is the outside-inside part of FOIL. This times this and this times this have to combine together to give you that. Oh my gosh, that sounds just ridiculously complicated. Well, let's start with the easy stuff. You're going to put an x here and an x here. X times x is x squared. Now we need to figure out what number goes here, what number goes here. And the trick is they have to multiply to 27. I'm sorry, they have to multiply to negative 27, and they have to combine to negative 6. Now, combine can mean add or subtract. It just depends on the signs. So here is the method. Take this last number and make a little chart. What numbers will multiply together to equal negative 27? Well, you can do positive 1 times negative 27, or negative 1 times positive 27, 3 times negative 9, negative 3 times positive 9, and I think that's it. Just knowing my times tables, that's it. Now just look through. Which pair of numbers are going to combine to give you negative 6? Well, 3 and negative 9. Positive 3 and negative 9 combine to give you negative 6. I'm going to emphasize this with a plus sign there. Positive 3 and negative 9 is negative 6. So put plus 3 minus 9, and we're done. We have sort of unfoiled this expression, the exact opposite of yesterday's lesson. Let me scroll down and check it, make sure that I didn't mess anything up. X minus 9, x plus 3. I have x plus 3, x minus 9. Does that mean I'm wrong because the answer key is like this? No, it does not mean I'm wrong. These two answers are the same answer. It's just like pick any pair of numbers. 5 times 2 is 10, and 2 times 5 is also 10. They're the same idea. So either one of those answers is fine. All right, let's look at number 8 and do it the same way. So you put down your 2 set of parentheses like we're going to FOIL something together, and it's going to start with k and k. K times k, k squared. Now we need 2 numbers that are going to multiply to positive 70 but combine to negative 17. So I'm going to make a little chart over here. Now this can get to be a real pain making this chart if the number is big. So look, to get a positive 70 you can do 1 times 70 of course, or you could do negative 1 times negative 70. Or you could do 2 times 35, or negative 2 times negative 35. And then it goes on and on and on. So I'm gonna clean this up a little. I'll give you a little tip to make this neater. So you could do, for 1 times 70, it could be positive 1 times positive 70, or negative 1 times negative 70. So if you just do it this way, you'll have like half the writing. 2 times 35, it can be positive times positive, or negative times negative. What else goes into 70? Well, you hopefully know that any number that ends in 0 can be divided by 5. What's 70 divided by 5? 24. Yeah, 24. By the way, feel free to use a calculator if you need to. Maybe I'll do a calculator on a future problem. Anyway, positive 5 times positive 24, negative 5 times negative 24. 10 will go into 70. Again, it ends in 0. 10 times 7. So positive 10 times positive 7, negative 10 times negative 7. And I think that's it. I think that's the whole table. Now, can you find any pair of numbers in that whole little chart that I've made that will combine to negative 17? Will negative 1 and negative 70 combine to negative 17? No, that's negative 71. I can throw out all the positive ones. How about negative 10, negative 7? Yeah, that does the trick. Negative 10, negative 7. They multiply to positive 70, but they add up to negative 17. If you really want to check yourself, besides scrolling down and checking yourself, you could FOIL it back together. I'm going to do it on this one problem. I'm not going to do it on any other problem. K squared minus 7k minus 10k plus 70. These are like terms. K squared minus 17k plus 70. So the fact that that gives me this means that I've done it correctly. You're probably not going to want to take the time to do that on every single problem, so I'm just going to erase this, pretend like it never happened, and scroll down and check number 8. And there it is, k minus 10, k minus 7. Okay, hopefully you're remembering this. It's not a big deal. It's something that you can do. You just practice a little and get good at it. Now this one is not a trinomial. There are only 2 terms here. This is what I referred to before as a difference of squares. Now the method that I have been using, will it work here? Take that last number, negative 100, and make a little chart. So it's 1 times 100. Now it could be positive 1 times negative 100 or negative 1 times positive 100. Also 2 times 50, positive times negative or negative times positive. 100 is also what? 5 times 20, positive times negative, negative times positive. 10 times 10, positive times negative, negative times positive. And that's it, because next I would get to 20 times 5, but I'm just repeating this one, so that's not worth all of the effort. There it is. So, okay, I need 2 numbers that multiply to this. That's what my whole chart is. And they need to combine to equal what? Well, there's not like that third middle term like there was on this problem. What is the middle term here? Well, if there is none, you could sort of think of it as being a 0. I mean, the number for nothing is 0, right? So what you really want to find is what pair of numbers add up to 0. Positive 100, positive 1 and negative 100, do they add up to 0? Of course not. But positive 10 and negative 10 do. So if I want to factor this, x and x, I can put a plus 10 and a minus 10. And like yesterday, these are conjugates. X plus 10, x minus 10 are exactly the same, except one has a plus sign, one has a minus sign. Now, when you start out with a difference of squares, like I just showed you, this method works as long as you kind of pretend there's a 0x in the middle. But there is a formula for difference of squares. So if you recognize, it's called a difference of squares because difference means minus, squares means either the variable is squared or you have a square number. Square number is like 1, 4, 9, 16, 25, 36, 49, etc. 6 times 6, 5 times 5, 8 times 8, 2 times 2, things like that. If you notice that you have a difference of squares and you want to factor it, and maybe you don't want to do this whole chart method, there's a formula. Okay, that parenthesis looks ludicrous. You just do a plus b, a minus b. Just square root each one of these, call them a and b, and then put them in that formula. So here, the square root of x squared is x, that goes here and here. The square root of 100 is 10, that goes there and there. Put a plus sign, put a minus sign, and that's it. So I've kind of explained two different ways to factor, oops, that was too much, to factor this problem. Use whichever method you prefer. And just for kicks, because I want to be consistent, I'll go down and check it. There it is. I hope you are always checking your work before you turn it in. Okay, number 12. This is back to being a regular trinomial. Take that last number, 32. Let's see, 1 times 32, that could be positive, positive, or negative, negative. 2 times 16 is 32, again, plus, plus, minus, minus. 4 times 8, plus, plus, minus, minus. 4, well, the next one would be 8 times 4. I'd just be duplicating my own work. So there's my whole table. So I put down an n and an n. These two numbers have to multiply to 32, add up to negative 12. So look at that little chart. Do you see any numbers that add up to negative 12? How about, oops, I need a highlighter. Negative 4 and negative 8. They add up to negative 12. So it's got to be negative 4 and negative 8. Or it could be negative 8, negative 4. Those both work. Either one of these would be the correct answer. Let me scroll down and check number 12. There it is. Okay. Now, at this point, those are fairly standard review Algebra 1 problems. It's about to get a little tougher. This is going to challenge you a little bit more. All of the problems from here on out have a lead coefficient. So lead means it's first. Coefficient is a number in front of a variable. A lead coefficient that is not a 1. If you look at this, n squared is technically 1n squared. X squared is 1x squared. K squared is 1k squared. X squared is 1x squared, right? The idea behind this is we still want to like reverse FOIL this, do the FOIL method backwards. But when you have an extra number here, it gets to be quite a bit more complicated. So what on earth do you do? Well, actually, not this. We're going to start with our little chart. And instead of taking this last number, putting it here and making my chart, you actually need to multiply the first number and the last number. And I'm going to use a calculator just because sometimes I get all into teaching and I make mental errors when I'm trying to do quick math. So I'm going to rely on the calculator for basically everything here. 7 times 12 is 84. So, and if you think about it, are you going to find two numbers that multiply to 12 and add up to negative 44? Absolutely not. That 7 there kind of throws a wrench in the works. It makes it much more complicated. So now I need to make this chart. And 84 is not the easiest number to work with. I mean, obviously 1 in 84, right? And they need to, well, yeah, I'll just leave it at that. There's the whole issue with signs. I'm just going to throw down a plus minus, plus minus. Let's see. 84 is an even number, so I can divide it by 2. Oops. 84 divided by 2 is 42. Can I divide 84 by 3? Let me backspace and change that to a 3. Yeah, 3 times 28. See, that's not something I would have just known in my head. I got to use a calculator. Can I divide this by 4? Yep, 4 and 21. I know I can't divide by 5 because it doesn't end in a 0. What about 6? Yeah, 6 times 14. Again, could be positive, negative, positive, negative. 7, doubt it. Oh, 7 times 12. What about 8? Definitely not 8. 9, no. 10, of course not. 11, I would seriously doubt it. Definitely not. 12, of course it does, but we're just reversing ourselves now. 12 times 7 is 7 times 12. So here's my chart. I used a calculator. Totally, definitely use a calculator yourself if you need to. But now what we got to do is we got to find pair of numbers that will combine to negative 44. So out of this whole chart, do you see any numbers that will combine to negative 44? I see negative 2 and negative 42. So here's what you do. You rewrite the original problem as 7a squared minus 2a minus 42a plus 12. Do you follow what I did? I took this term and I split it into minus 2 minus 42. Now we are going to do, at this point, common factoring, just like the first couple of problems. But we're going to focus on just these first two terms. What do they have in common with each other? 7 and 2 have nothing in common. You can't divide anything out of 7 and 2. You could argue divide out a 1, but that doesn't change them. They're still a 7 and a 2. But the terms both have a, so you can divide out a common a. That's going to leave us with 7a minus 2. Now look at the next two terms. What do they have in common? Well, 42 and 12. Let's see, what can you divide out of those? You divide out a 2, but I think you go with a bigger number. You can divide out a 6, I think. Let me check. 42 divided by 6 is 7. 12 divided by 6. Oh, I'm dumb. You know 12 divided by 6 is 2. Ah, rats. Of course. So I can divide out a 6. And because there's a negative here, I'm going to divide out a negative 6. That's going to leave me with 7a, right? Negative 6 times 7. And a negative 2. Negative 6 times negative 2 is positive 12. So this is getting deep. This is a very complicated method for doing this. Again, if you have another, go for it. But we're about halfway through this. Do you see how these two sets of parentheses match each other? That means 7a minus 2 is half of our answer. Remember, we're trying to do something that looks like a FOIL method here when we're done. So 7 minus 2 and 7 minus 2 match. That's half our answer. The other half of the answer is the a and the minus 6. A minus 6. If you FOIL that together, you will go back to the original problem. Let me check number 14 just to show. There it is. All right. Was that too much? Yeah, I understand if you say it was. If you learned this method before, this is just a review. If you've never seen it before, it might take a couple of tries to get it, have it sink in. Number 16 is the exact same thing. We got a lead coefficient, so we're going to have to do this method. Multiply 2 times negative 20, that's definitely negative 40. So what's negative 40? 1 times, not 20, duh. 1 times 40, plus, minus, minus, plus. 2 times 20, plus, minus, minus, plus, or whatever. 3 won't go into 40. 4, of course, 4 times 10, plus, minus, minus, plus. 5 times 8, no, you know your times tables. 5 times 8 is 40, plus, minus, minus, plus. And I think that's it. Now, can you find any pair of numbers in there that will add up to positive 3? I believe a negative 5 and a positive 8. So 2p squared minus 5p plus 8p minus 20. Right? These two add up to equal 3. Now we're going to do that common factoring again. First, just do the first two terms. What do they have in common that you can divide out? 2 and 5 have nothing in common. Both terms do have a p. If you divide out a p, you're going to be left with 2p minus 5. So take a p out of both of those, and you're left with 2p minus 5. Now look at the next two terms. What do they have in common? Well, 8 and 20 can both be divided by 4. So I'm going to factor out a 4. That's going to leave me with 2p minus 5, right? 4 times 5 is 20. 4 times 2 is 8. Once again, these match. Now, for this method to work, what I just highlighted, it has to match. If they don't match, you've done something wrong. You've got to go backtrack and do some refiguring. So that means to make this look like a FOIL problem, the first part of the answer is 2p minus 5. The second part of the answer is this p and that plus 4. P plus 4. By the way, you may have heard this before referred to as the grouping method. I don't really care if you call it that or not. I'm just throwing that out there. Let's check number 16 and make sure I did it right. There it is. Number 19, again, repetition. Just repetition for the sake of repetition, and make sure you get it. Multiply these first and last numbers. 6, no, that's a 9. 9 times negative 7 is negative 63. Make a little table out of that. 1 times 63, plus, minus, minus, plus. 2 won't go in there, 3 will. 3 times 21, right? Plus, minus, minus, plus. Let me go to the calculator. Can you divide a 4 out of a 63? Nah, it's not an even number. 5, no, 6. 63 divided by 6. Oh, darn it. If I could learn how to use this calculator, right? 63 divided by 6, not so much. Divided by 7, yeah. 7 times 9, plus, minus, minus, plus. 8. 63 divided by 8, no, of course not. That takes me to 9, which is already there, so that's my table. That's complete. What pair of numbers out of that table, that chart, are going to add up to negative 18? Well, I did write something a little incorrectly, and it would really throw us off. Negative 3 plus 21. Negative 3 plus 21 is 18, negative 18. No, that's wrong. Actually, it's got to be positive 3 and negative 21, doesn't it? To equal a negative 18, I need the bigger number to be negative. So, 9x squared plus 3x minus 21x minus 7. Look at the first two terms. What do they have in common? This one's a little more complicated. You can factor out a 3 and an x from both of those. Divide 3x out of 9x squared, it's going to leave you with 3x, and then a plus sign. 3x divided by 3x is just 1. Out of the next two terms, negative 21 and negative 7, you can divide out a negative 7. And that's going to leave you with 3x, right? 3 times negative 7 is negative 21, and a plus 1. Negative 7 times positive 1 is negative 7. Do you see how this matches that? That means we're doing it correctly. So half of our final answer has got to be 3x plus 1. The other half is going to be 3x minus 7. Check number 18. And there it is. It's backwards, but again, that doesn't matter. 3x minus 7, 3x plus 1, same thing. Okay, number 20 is our last one. And it looks a lot like 18 and 16 and 14, right? It's got a lead coefficient. So do we have to do this method to it? Well, we could, but I want to point something out. If you look at all three terms, they're all divisible by 2. They share a common factor. That was not the case in the previous problem. 9 and 9, okay, there's a common factor in 9 and 18, but not in 7. So there's no overall common factor in that problem, but there is in this problem. If there's a common factor, go ahead and divide it out, like undistribute it. If you take a 2 out of all of these terms, you're going to have v squared plus v minus 12, right? 24 divided by 2 is 12. Now that 2 is already factored. It's done. There's nothing else to do with that. When you look at what's left over here, v squared plus v minus 12, there's not a lead coefficient anymore. So this is actually an easier problem. It's more like the first set that we did. All we got to do is take negative 12 and make a little chart. 1 and 12, which could be plus minus or minus plus. 2 times 6, plus minus minus plus. And 3 times 4, right? That's all you can do to multiply together to get a 12. So that's our little chart here. When we go to do this factoring, you can just automatically put down a v and a v. What numbers now multiply to negative 12 but add up to equal, well, what is that number there? If there's no number, it's a 1, right? What pair of numbers are going to add up to equal a positive 1? Positive 2 minus 6? No. But negative 3 plus 4. Negative 3 plus 4 equals a positive 1. So negative 3 plus 4, and that should be our answer. Or possibly v plus 4, v minus 3. Notice you still stick that 2, that's part of your answer. It still belongs there. But one of those two things is going to be our answer for number 20. And there we go. Okay, time to stop. Number 19 is like number 20. You're going to have a common factor to divide out first, and then the rest of the factoring will be easier. The rest of the problems are sort of paired up, so you can use the same methods as you go through. Again, that whole method that I've been working through, if you don't like it and you know how to do these problems another way, obviously besides just cheating and looking at the answers, then do it. Show whatever work you do, check your work before you submit it. If you have questions, please contact me. I'll do my best to help you. Otherwise, I will talk to you later.